Hey everybody, we're going to go through some problems here real quick to help you on your quest for finding the awesome bits of radicals and their knowledge. Anyway, we're going to do three problems here. We got to keep it below 5 minutes. That's what we're going to try to do. So what we have is the first problem. It says, use the rules of exponents to simplify the expression. Write your answer with positive exponents. Assume all variables represent positive real numbers. So that's good. So let me rewrite the problem. P to the 1/4 times the whole quantity P to the 3/4 minus 3 to the P over 7/4. Well, this is easy. We're just doing distribution, right? So we distribute. So the first one that we're going to have is P to the 4th, right? Times what? P to the 3/4, right? Now let's do another one, another color. Now we have minus P to the 1/4 times the quantity 3P to the 7/4. Okay? Now, the only thing that you really need to keep in mind here is that when you have the same bases, right, and you're multiplying them, what you do with their exponents is simply add them. Okay? So what we have here is going to be P to the 1/4 plus 3/4, well that's nice, minus P to the 1/4, 3P to the 1/4, oh no. Yeah, that's fine, I can do it that way. Yeah, but maybe not because I don't want to confuse you. So we'll do P to the 4th, right, plus what? The 7/4, right? Now the only thing that we're missing is the factor 3. Okay, so I was going to do it in a different way, and I hope I didn't confuse you too much. Let me fix this so it makes it look like a little bit more of a subtraction. And let me put this back down so it looks a little better. Okay. So now all we have to do is combine them. So this is P to the 4/4, or 1, minus 3P to the 8, right? 7 plus 1 is 8. 8/4 is 2. So that would be our answer. We cannot combine a degree 1 and a degree 2. All right. Next one we're going to go through. Sorry about that. I wanted to try to do it a little quicker, but I wanted to make sure every step was understood. So, all right. So now we're going to combine. It says add. Assume all variables represent positives. So let me rewrite the entire problem here so we have it in front of us and make it easy. And make sure that I don't make a copy error. Okay, so what I'm going to do is off to the side here, I'm going to simplify each radical. Okay? Or better yet, what's underneath the radical or the radicand. So in the first one I'm going to do is red, and that's the square root of 20y. Well, that's easy. That's the square root of 4 times 5 times y. Well, we know that the square root of 4 is nice. We know nothing about the square root of 5 exactly. We know nothing really about the square root of y. So once we do all this simplification, this becomes 2 times the square root of 5y. Now I'll do the other one in purple. So we have the square root of 45y cubed. Well, we're going to break it down into perfect squares again. So let's break it down. This is going to be 9 times 5 times y squared times y, right? I'm breaking up the two y's because I have y squared. Now, technically, when we do this, it should be the absolute value of y, but we're just working with this and doing out the basic problem. So now we just do the square root of 9 times the square root of 5 times the square root of y squared. And remember, that's what I said should be really the absolute value of y, but don't worry about it right now, times the square root of y. So when we put this all together, this should be 3y square root of 5y. So notice that the radicals are the same. I'll highlight them. Notice the radicands, actually, what I should say is the same. And now let's put them back together. So this is 6y times something, right, plus 3 times something. So let's put the right colors in. I think I used red first. So this is 2 root 5y, and I used purple, I think. This was 3y root 5y. So now we can just do the basic multiplication and then combine. So this becomes 12y root 5y plus 9y root 5y, which tells us that this should be 21y root 5y. You guys okay? So what we're looking for is the combination, simplification, and the process there. So you have to simplify each radical first, and that makes the process much easier to work out. Okay? Okay, rationalize the numerator. Okay. So the numerator here is simply 5 minus the square root of 3. So its conjugate is the same thing, except the symbol between them is altered. So if it's a difference, then we have a sum. If it's a sum, then we have a difference. So now we can work out the problem. This is 5 minus root 3 all over 6, and I'm going to multiply numerator and denominator by that conjugate. 5 plus root 3 over 5 plus root 3. Now, remember, one of the main reasons why we actually talked about the difference of two squares when we were factoring, remember, if we have this setup, right, a difference of two squares, then we know we can factor it accordingly, right? Two binomials, one that has a plus b, one has a minus b quantities. Well, notice this. This is a and b, and there's a negative between them. Here's a and b, and there's a positive between them. So we can just do the simple way of doing this out. We just label what's a, so 5 would be a, and the square root of 3 would be b. So we can do this multiplication very quickly if we're on top of things. So what would we do? We would take a squared, so that would be, let me say 5 squared, that's a horrible 5, minus root 3 all squared, and that product will give us what? 25 minus 3, which gives us 22. So now we know the numerator is 22. The only thing we have to do is multiply the denominator together, right? So that would be 30 plus 6 root 3. Now, that might be a suitable answer, but there's a little bit of an issue, right? We should ask ourselves, can we reduce? And the answer is everything here is divisible by 2, right? So if we can reduce, why not try? So I see that 22 is 2 times 11. I see that 2 times 15 is 30, and I see 2 times 3 is 6 root 3. Notice each one of them has a factor of 2. So it looks like if we do the reduction that we have 11 over 15 plus 3 root 3. All right, I hope this helps. Let me know. Thanks. Bye.